Identify MAC and IP addresses. Gather PDU information for local network communication. Click 172.16.31.5 and open the command prompt. 172.16.31.5. Click here. Desktop command prompt. Ping 172.16.31.2. Okay, ping from 5 to number 2. Ping 172.16.31.2. Enter. Success. Switch to simulation mode and repeat the ping. Okay, click here to change to simulation mode. Okay, click on 5 and repeat the ping. Enter. You will see the PDU. A PDU appears next to 172.16.31.5. Okay, this PDU. Click PDU. Click on the PDU. Okay, click here or click here. OSI model and outbound PDU layer tabs. OSI model and outbound PDU details. 2 tabs. Destination MAC address. Okay, this is the destination MAC address. On outliers column, zero 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 C 85 CC 1D 87. Destination MAC address, source MAC address. This is the source MAC address. Source IP. Source is 5, destination is 2. Source IP address 5, destination IP address 2. Add device 5. Okay. Close this and you can see here add device 172.16.31.5. Click capture forward to move the PDU to the next device. Okay, this is the capture forward button. Click here. Okay, the next device is the switch. Gather the same information from step 1D. Okay, all this information, but click on this new PDU. The PDU on the switch. Okay, and there is no layer 3 information, no layer 3 information, only layer 2 and layer 1 information. The source MAC address is 00D0D311C788. The same source MAC address of the previous PDU, and destination MAC address 000C85CC1D87. The same MAC address of the previous PDU. Record the PDU information you gathered into a spreadsheet using a format like the table shown below. You can use this. Okay, and close this. Capture forward. and PDU goes to hub. Click here. Only layer 1 information, because hub works only on layer 1. A hub only works on layer 1, switch on layer 2. Capture forward. Click here. IP information, layer 3 information, layer 2 information, and layer 1 information. Okay, close this. Repeat the process in step 1 and gather the information for the following tests. Ping 2 from 3. Okay, go to real time, go to simulation again, and ping 2 from 3. Okay, access to 3. Desktop command prompt, ping 172.16.30.1.2. Enter. You can see the PDU. Click here. Okay, layer 3 information, source IP 3, destination 2, no layer 2 information. Close this, capture forward. Okay, now you have a second PDU. Click here again or click here. And now you have the layer 2 information. The source MAC address and destination MAC address. Source MAC address, the MAC address of 172.16.30.1.3, and the destination MAC address, the MAC address of 172.16.30.1.2. Capture forward, goes to hub, only layer 1 information, capture forward, click here, source IP, destination IP, source MAC address, destination MAC address, ping 4 from 5. Okay, go to real time, simulation. Okay, access 5, click here, and ping to 4, 31.4. Now you can see the PDU, click here, layer 3 information, source IP 5, destination IP 4, close this, capture the forward. Okay, there is a second PDU, you can click here, layer 2 information, source MAC address, destination MAC address, capture them forward. Okay, PDU goes to switch, click here, only layer 2 and layer 1 information, switch works on layer 2. Click here, and PDU goes to destination, click here, layer 3, layer 2, and layer 1. Okay, remember ICMP ping works on layer 3. So that's why PC can show layer 3, layer 2, and layer 1 information. And don't forget that PC can work from layer 1 to layer 7. But in this case, only shows layer 3, 2, and 1 because ICMP ping works only on layer 3. Return to real time. Click here on real time. Gather PDU information for remote network communication. Okay, this is the local network, local area network, but this is the remote network. Gather PDU information as packet travels from 5 to 10, 10, 10, 2. Okay, from 5 to 10, 10, 10, 2. Click 5, command prompt, ping 10, 10, 10, 2. Click 5, command prompt, ping to 10, 10, 10, 2. Enter. Success. First ping fails, but all success. Simulation mode, repeat the ping. Simulation mode. Click here on 5. Repeat the ping. You can see the PDU. Click the PDU. Click this PDU. Destination MAC address. Okay, source MAC address. Source MAC address 00D0 D3 11 C788. Source MAC address 00D0 D3 11 C788. Destination MAC address 00D0 BA8E 741A. Destination MAC address 00D0 BA8E 741A. Layer 3 information, source IP is 5, destination IP 10.10.10.2, source is 5, destination 10.10.10.2, add device 5, close this, add device 5. Okay, very good. What device has the destination MAC that is shown? Okay, what device has this destination MAC address? Okay, and go to real time. Okay, first verify the source MAC address, and should be the MAC address of the source, the number 5. Click here, ipconfig/all space/all, enter. Now you can see the MAC address 00D0 D311 C788. Okay, very good. Match. And what is the destination MAC address? Review the MAC address on 10.10.10.2. Desktop command prompt ipconfig/all, and the MAC address of 10.10.10.2 is 00C60128448B6, and it's not this. Okay, and where is this MAC address? Go to the router, command line interface, verify what interface is this, fast Ethernet 10, and use the following command: show enable show interface fast Ethernet 10, enter. and review this. 00D0BA8E741A. 00D0BA8E741A. Match. What device has the destination MAC address that is shown? The MAC address of the interface FastEthernet 10 on the router, on this router. FastEthernet 10 on this router. Source IP address, this source IP address of PC number 5, destination IP address 10.10.10.2, 10.10.10.2. Very good. Click Capture Forward to move the PDU to next device. Okay, go to Simulation, click on 5, repeat the ping, 10.10.10.2, enter. You can see the PDU, click on the PDU, layer 3, source IP is 5, destination 10.10.10.2, source MAC address, the source MAC address of the PC number 5, destination MAC address, the MAC address on the router. Close this, capture forward, PDU goes to the switch, click here. Only layer 2 information, click here, goes to the router. Okay, router works on layer 3, so that's why you can see the layer 3, 2, and 1 information. And you can see here the outliers column. You can see the destination MAC address is 0060 2F84 Click on 10.10.10.2, and is this 0060 2F84 the destination MAC address. Okay. And remember, MAC address is only relevant only in local area network. Okay, capture them forward, goes to the switch, click here. Switch works on layer 2. Capture them forward, goes to access point, layer 1 information, capture them forward, click here. Okay, ICMP works on layer 3, so that's why you can see layer 3, 2, and 1 information. Repeat this process until the PDU reaches its destination. Record the PDU information you gathered from pinning 172.16.30.15 to 10.10.10.2 into a spreadsheet using a format like the sample table shown below. This. Reflection questions. Okay, different types of cables media used to connect devices. Okay, go to real time. This is copper. This is fiber. And this is wireless connections. Okay, so the answer is copper, fiber, and wireless. Did the cables change the handling of the PDU in any way? No, cables only work on layer 1. Did the hub lose any of the information that it received? No. What does the hub do with MAC addresses and IP addresses? Nothing, because hub works only on layer 1. Did the wireless access point do anything with the information given to it? Yes, it repackaged it as wireless AO 2.11 frames. Was any MAC or IP address lost during the wireless transfer? No. What was the highest OSI layer that the hub and access point used? Only layer 1. Did the hub or access point ever replicate a PDU that was rejected with a red X? Yes. Okay, because hub access point replicate the PDU to another PCs. When examining the PDU details tab, which MAC address appeared first, the source or the destination? Okay, go to simulation, click on 5, repeat the ping to 10, 10, 10, 2, enter. You can see the PDU, click here, click on PDU details, in this case outbound PDU details, go to Ethernet 2. Okay, this is destination address and this is source address. So first destination address. Close this. Okay, the answer here is destination MAC address. Why would the MAC address appear in this order? Switch can begin forwarding a frame to a known MAC address more quickly if the destination is listed first. Was there a pattern to the MAC addressing in the simulation? No. Did the switches ever replicate a PDU that was rejected with a red X? No, because switches only sends the frame to the destination, not to another PCs. Every time that the PDU was sent between the 10 network and the 172 network, there was a point where the MAC address suddenly changed. Where did that occur? It occurred at the router, because MAC address is only relevant in the local area network. Which device uses MAC address that start with 00D0VA? Okay, remember this destination MAC address 00D0VA. This is the MAC address of the router. Okay, the router. What devices did the other MAC addresses belong to? To the sender and receiver. Did the sending and receiving IPv4 addresses change fields in any of the PDUs? No. When you follow the reply to a ping, sometimes called a pong, do you see the sending and receiving IPv4 addresses switch? Yes, because PCs change the roles for the source and destination. What is the pattern to the IPv4 addressing used in this simulation? Each port of a router requires a set of non-overlapping addresses. Why do different IP networks need to be assigned to different ports of a router? The function of a router is to interconnect different IP networks. If this simulation was configured with IPv6 instead of IPv4, what would be different? The IPv4 addresses would be replaced with IPv6 addresses, but everything else would be the same because IPv4 and IPv6 works only on layer 3. Thank you very much.